Well, okay. Okay. It is time to continue doing things. Did I check in the earlier things? I think I did. Maybe I didn't. Oh, I didn't. Okay. I will want to, though. Look, I have some. Oh, polymorph depth. I didn't do that. Also copy inferred types. Yes. Yes, very good. Okay. Okay. I feel like this is old code that should not be necessary. But I'm not sure. Oh my God, there's so many callers. WTF. Okay, this is dynamic respecialize. But regular struct polymorph doesn't. Okay, we need to pass the depth in here. And then because it's C++, we have to have 20 trillion declarations of everything. And then this is the other caller, and that's the other caller. Okay, so weirdly, this is something that gets done for dynamic respecialize. And I think, okay, I think that's a cheating way. Does bind constants block entry not actually do this? It actually does, though. I feel like this is maybe old. Let's try completely commenting it out and running all the tests again in debug. Definitely some of the tests use dynamic respecialize. So they may fail if that was important. But if it is important, I want to move it out of the core thing and back to the caller. Because, yeah. Read more Tobiord. Yeah, maybe. I mean, that's a good paper. I just wanted to get some more programming done tonight. Like sometimes if you do just an extra hour or two before bed, that's the extra velocity that you need to win, right? Imagine you programmed in the game industry for 10 years and some other dude also did, but then he also did an extra 90 minutes half the time before he went to bed. That dude's going to kick your ass. All other things being equal anyway. Okay, yeah, I feel like this is an old thing that is no longer effective. So we're going to get rid of that. However, we're going to pass in polymorph depth, which might be temporary. We might get rid of it again later. But there we go. All right, so and then the caller, which should be right up here, this one, is going to also say polymorph depth. How is this one using polymorph depth? completely ignored right now. Great. That's great. Okay, so this goes polymorph depth. And that's my other no check-in, and that should be both of them. So then I can check in if we pass all the tests now. What's the console called? It's the Nintendo 65. Everyone would like a Nintendo 65, wouldn't they? Wouldn't they? Nintendo 68. All right. When's the Starbase office opening? Well, it depends on Starbase actually being an actual place. Okay, like if that's just his cute name for the area of that's technically Boca Chica, that doesn't count. But if he actually starts a business-friendly city in Texas, then yeah, totally we're opening an office there. All right, so further refactoring of Struct Polymorph. Okay, that's great. Now, as we were doing in the streams, I've done some stuff between this morning's streams and now, but as we were doing, we're sort of migrating the Struct Polymorph code so that it's more in line with the procedure polymorph code and they can share more and the Struct Polymorph will be as powerful. And, well, I think the next step, so basically now we actually make a poly proposal and we use it to make the struct from the proposal. Now the next step, we actually apply the modify directives after we make the struct, which is actually probably not good because, well, it depends. Anyway, you probably actually want to check for duplicates. Maybe both before, okay. We probably actually want to check for an already existing polymorph both before and after running modify directives, since otherwise we will run modifiers a lot and this can be very slow. For now, we don't do this yet, though, and we just do it on the final constants block because, hey, we are getting things to work. Okay, that's got a speed note, and it'll be easy to do the other thing later, I think. Okay, so we make a struct from the proposal here, and then we apply modify directives. In the procedure form, we also have an apply modify, but it happens on the prop, right? And so in order to migrate back more in the lines of how procedure polymorph works, and also probably to enable us to do this checking more easily, we could actually just move this a little bit. Actually, yes, and it's good to do that before yielding. Okay. Or it's good to yield before making the result. I mean, I guess it doesn't matter. Well, whatever. It's fine though. Okay, so we're going to apply the modify directives to the props constants block. Okay, and okay, great. So I think we just test that. Again, we're just going to be testing a lot today. This is the kind of change where I tend to go in relatively slow incrementals, just because if I make a problem, it could be hard to figure out what's going on with a system like this. And so realizing that I made a mistake as soon as possible is good here. Well, we are still building. Going to hack me from seeing the monitor. What you are able to see on the monitor is the Twitch chat and panel. I'll show you. See how you can see like that purple column on the monitor? I will show you right now exactly what you are seeing. It's these buttons right here. And now, oh wait, no, that's not what, oh yeah, okay, never mind. Because here, that's an old picture, but now you see a different background. You see a random web page that's bright now. Okay, so I'm putting this back. Yes, and you sort of see the purple column again. So have fun. Have fun hacking me. From knowing my sub count. Yeah, exactly. The sub count's pretty low these days because I haven't been streaming regularly. It tends to hover around, like when I stream, oh, well, I guess it went down permanently. I think people either got bored of Twitch or COVID means people have less money to throw at Twitch or something. But I feel like most streamers kind of declined between, like of course, some people go up, but on average between like June 2020 and February 2021, I feel like there was a dip. And so on this channel, we were about 250, 260 last year, and we're about 220 this year when I stream regularly, but I haven't even been streaming regularly. So like we're way down. We are way down. Try asking for Twitch Primes. You heard purple is a fake color. It is a fake color, I guess. Okay, so these things are still working, which is great. I'm not going to be a chicken and check in just off that. What am I going to do? What am I going to do? I'm going to go one more step at least before checking in. So we do our proposal. We run the modify directives. So I'm just going to put a note up here. Detect duplicates. Okay. Actually, let's reverse this. Let's put this note down here. We'll put this one up here because it's right before the thing that's actually slow, which is running the modify directives. Okay. Now, oh, this constants block type or value confusion, I think, is probably fixed. Oh, maybe not. interesting, yes. We're going to leave that. Okay. So this get inferred type, it's an inline procedure right now. It's bad form to call that more than you need. And it will have like a slow path probably eventually when things are parallelized, which is why you want to minimize it. Although that slow path would not be invoked here, it's just more code and stuff. Should cover 0.01% of my rent in SF. I mean, actually more than that, but yeah, it would not cover my rent in San Francisco. That is for damn sure. That is for damn sure. Okay. Okay. So we do some stuff, and then we do some stuff, and then we go live. I mean, I just want to clean this up. Yeah. Actually, no, you know what? Forget it. If that one's null, then this one's allowed to be null. All right. Forget it. Forget about it. We're just going to run a test on that because why wouldn't we? Okay, so I want to migrate this further in the direction of being usable for the other thing. Now, what I kind of want to do is use the same polymorph state struct, maybe, question mark, or make a different state struct for this, because this yielding down here, this is a thing, okay, it's quite possible that we're yielding a lot. In fact, I actually want to do something here. Don't ever use static variables. We're going to delete this. So I just want to know how many times we yield here, because this is actually slow, because if we yield and come back, we're doing all this work again to repolymorph the struct, and that's annoying and stupid, right? So we could make a state struct for that. And that actually might speed up the compiler tangibly. There's some case in which that does. Because like I have not profiled this compiler in a long time. Okay, well it didn't do anything there. How about here? Okay, well we literally never yield there, so I'm not going to worry about it. Right? Like we were up to date, yeah. Okay, we never seem to yield here. but in theory it can happen. So anyway, it's maybe not a speed concern then, actually. But actually also, we don't actually know if this works if we yield here. That's the thing. Like, that's all the people who think that they're doing exception handling have no idea if their code works because they don't ever test the exceptions. Same thing here. If we don't ever yield here, we don't actually know that this is going to work when it happens. Okay. Whoops. Here we said before we make a result desk, let's see if we have a match. Okay, so that's actually better. Whoops. Like, this used to be down here a long time in the code, and then it moved up there, and now it's moved down here again, which is good. And I could put this in there. Okay, let's test that again. We're just testing every little step today. More cautiously than I normally would be, like I said. Because we are treading on perilous ground. Okay, so we have a struct polymorph. We have another struct polymorph. So yeah, so let's move our modified directives ready out of here because both of these guys call it, and it's sort of in between both overloads of struct polymorph and the text file, which is awkward placement. Okay, so how big is the compiler these days? Let's see. Woof, we're getting up there in line count. That's what happens when I keep typing code, guys. How do I reduce the code? Okay. Well, you know, now that we have a Bitcoin rocket in our emotes, I'm sure that the subscriber count will follow the direction of the Bitcoin rocket. Delete some files. Yeah, we could do that. We could do that. Delete some files. Okay. You're kind of convinced making code smaller is impossible. I mean, I have done it sometimes. It is pretty hard though, dude. It's hard. Like yeah, it's hard. Smode caller, yeah. Smode caller is hard. You bet self-hosting would reduce the line count. Yeah, it would, honestly, by quite a bit. By quite a bit, probably, maybe. Okay. What is my next step? That all passed. Let's commit again. All right. Now what? Well, I think we want to try to get the $T, in my opinion. So like this thing still won't work. Oh, wait, no. That is a different thing that I was testing. So our original thing was commented out. Let me go back to this. Oh. Okay, yeah, we're back to circular dependencies, which is, again, not a surprise. Not a surprise. Because we're not defining T still. So let's try it. I could get it working in the non-looping case. Right, okay. So what we want to do is maybe get it working in the simple non-looping case. Okay, either we could get it working first with pasted in code, or we could use a polymorph match progress instead, and then we could just call this instead. That actually might be a good idea. Might be a good idea. How can it be what circular? Not everything is circular. I'm kind of tempted to just do this. Okay, what is polymorph match progress? We say what the inputs are. Okay. And then we have one of these on asked polymorph. So that's another thing we could do to make struct polymorphing more robust. Is actually, okay. I mean, this is annoying because we go all the way to like poly proposal and all this stuff. But I think for the same reasons I was saying this morning about it's a little worrisome to add more temporary things, I think in this case for robustness, it's actually correct to do this. And then we could try to optimize it later. maybe. Oh, you thought the next thing was circular dependency handling. No, I mean, that circular dependency is an incorrect error message. Like, it's really just that we're not defining part of the struct that it needs in order to compile. So that's all. That is all. So, desu ka. So, like, if I make one of these, then this controls all the yielding and so forth. Okay, so, and then I guess one of these is made by, okay, we could hook this up. Who makes this? So we make this Ast polymorph. We fill out these things. Yeah, let's try it. Because again, like, polymorphing has to be very robust in this language. It simply must be. And there will be ways that we can accelerate these things. Like, yeah, okay. So, yeah. Okay, so we're going to say will be either struct or lambda. Okay. Okay, I think we go with this. And what I can do is I can create this when we do the struct polymorphing, and then just shortcut it so that it doesn't do all the steps and just does what we do now, and then we can add the steps, supposedly. This is... maybe this will be or struct. I don't know. Let's get there. I mean, I'm not sure. Like, do we skip polyproposal if it's not an overload? I don't think so. What's going on? Result prop or lambda? Oh, because if we get a deduplicated, right. If we deduplicate the polyproposal, here, we could just return that. Okay, great. Great, great, great. So we're going to say this is prop lambda or struct. Either is not. Okay. This is maybe, I thought this variable would be used less than it is. Okay. So actually, let's keep this comment. Shorten that up. Right, so the job of this thing is to keep okay. So what we want to do here is say if we're doing a lambda, otherwise we do the struct polymorph. Okay. We need like a call. Okay. Actually. Yeah. Okay. Let's not do this part yet because we can't get here yet. Actually, we're going to check in. So we're just going to, again, we're laying foundation to do this thing, but we're not actually hooking this up yet. So we're still going through the old pathway to polymorph structs. What we're going to do is down here where we're calling struct polymorph, we're instead going to make we're going to make an ast polymorph like before. And then return that. Actually, do we not set substitution on that? I guess not. Anyway, so I'm going to actually even insert all this code to do this. Do we have silent check? No. Oh, well, we won't worry about it. Okay. Frack. What's the tag that I put on these? Unify polymorph. This is my little tag that says these are the things that are sort of on the to-do list until this task is done. We don't want to do this part yet because this is what actually makes this like live and happening. And we don't want that. Okay, but this needs to get renamed right here because we changed that to source. Okay. Okay, so and then this is kind of bad style here, I guess. Okay. Okay, very good. Very good. Very good. Very good. Okay, this won't compile for some reason. Yeah. Whoops. So that's weird. Okay, I guess we do the sort arguments. Right. We would do the sort arguments here. Right now they happen in Struct Polymorph. So we would do this and then, yeah, okay. Okay. But we're just going to run tests with all this and check it in again, even though none of this stuff is enabled, because that's how you succeed in the games industry. How's it going, everybody? Is everyone out there succeeding in the games industry? I hope so. I hope y'all are. I'm having a good time in the games industry sometimes. Not always. Not always. Sometimes, though, it's pretty good. Sometimes it is pretty good. Does drawing a rectangle to the screen say how to succeeding? Yes, actually. Look, dude, in the old days, it would sometimes take me more than a day to get to the point of having something on the screen. So, like, that is the smell of success. That is the smell. 2 rectangles. Oh my God. Look, listen. Okay. When you go pitch to the venture capitalists, they want to hear about your growth rate, right? So like if you had one rectangle yesterday and two rectangles today, your day over day growth is 2x, which is insane. They'd be fools not to invest. It's like the chessboard with the rice on it. Okay, so this is great. So we're going to say here, prepping to change the route by which we get to struct polymorph. Okay, so that's great. Okay, so now we've got this asked polymorph that we are making. Let's sort the arguments. See, this is a special thing where we're trying to yield, but this is already going to be handled elsewhere. So, okay, here's where we do sort arguments. So we're going to do it right here. Thing is, we don't really have a place to put it. That's fine. We'll put it on the thing itself. Okay. Okay, so we're going to do that. And we're going to go sort arguments. So source desk here is just desk. Vargs info. Oh, that's good. Okay. So we're going to return true. And we're still not going to do anything to like queue this up and make it live. We just want to make sure this part works. What is this thing here? just reporting mismatches. Like, right. So that'll be taken care of by the other thing that we're going to do. Okay, so we're just doing this. That's fine. So I made these things, and we're going to need to define those. Actually, does this have like argument list? It does. Oh. That's great. And then varargs info, is that on call as well? Yes. So never mind. We don't need to add separate storage for that. Okay. This is great. That's great. Okay. Still won't do anything. Still won't even compile. Sort arguments. Cannot convert from array to reference. Argument 3. Great. Wonderful. Why is there a reference there? I don't know. Okay. C++ is so silly. Doh. Okay, well. Sort arguments is crashing. Is it crashing? Let's try running it on the game. Yeah. This is why we're putting it in separately and testing it before hooking it all up end to end. All right. So, sham bam bamina. All right. argdecal inferred type is going to be null. Okay. The hell is argdecal? It's on the struct. So we actually do need to do the thing that we were doing before. Okay. So we used to call struct polymorph. Oh, we're going to be able to get rid of force infer. Holy shit. Oh, hopefully, maybe not. Anyway, okay. So all we need to do here is before we do this sorting, we're just migrating some of this stuff. Right? Like you think you're going to delete some code and like it doesn't actually quite work out that way sometimes. All right. Okay. This is not redundant, actually. We need to actually yield there. Oh, there's no frick. Oh, never mind. Yeah. Let's do that. Okay. Okay. This is great. This is very good. We have just hit the 1 hour mark on the stream, and this is very good. Okay. Now I'm going to check this in, and then okay, so we're going to do this. We're doing argument sorting, blah, blah, blah. Okay, this is... These probably should have been up there, but whatever. Okay, so now, as soon as we do this, who sets force infer structs? I kind of feel like we don't want to do that. I kind of feel like we ignore this, which is good. I will be happy to get rid of force infer structs. Bane of my existence, force infer. Okay. This is very good. Very good. Very good. Very good. Okay. I just committed, right? Did I? Did I? Yeah. Okay. So now we want to throw switch. And the thing is, we want to push and flatten this thing and then return true. All right. That is very good. Now, though, what does that mean? It means when this thing gets inferred, now it is going to, oh, this is actually bad. Bad equal placement, that's deceiving. All right. Let's do that. This is the part that's mildly scary, but hopefully not too bad, because it's sort of been done a lot by other things. Okay, so this infer types for polymorph. Um, here we go. So this part where it's a struct, we need to do the thing. And we probably want to factor this around a little differently than it is. So this is just code that I pasted from the other place. Okay. Okay. I kind of feel like that shouldn't happen. Okay. So then if we get here, we're just going to set this to this. New struct, and then hopefully that exists. Still, okay. Blah. I don't even know what that. And then here, we go back to the call. Oh no, we do the result. Yes, okay. Which actually, yeah. Okay, very good. Very good. Surely there will be many problems with that. Oh my God, are you serious? It's actually working? Are you kidding me? Are you kidding me? Okay, well, sometimes we succeed in the games industry. I don't know what to tell you. If I want to replace the colon with section, how would I do it? Very easily. Say I want to remove the return type function to a front. Could you write a meta program to update your existing code? Yes. Like, I've demoed these so many times. Yeah, it's easy. Like, we've had the capability to do that shit for years. Like that was a pretty big change, yes, but it also it was following in the footsteps of things that we have done before, but I'm a little surprised. Let's do this. Like, just to make sure we're not freaking hallucinating, because that's like, I can go to bed happy to, oh, look at that. Look at all those cowabungas. So that means this code is actually being exercised quite a bit, in fact. Okay, so now I want to do this part. Let's see if that breaks something. It might, which is why I typed it in a comma. Oh yeah. Oh yeah. Okay. Let's not do that yet. Anyway. That could be why. Could be why. Okay. It might be bedtime for me. Like, this is, oh, happy day. So this is good because we're going through an Ask Polymorph now. Oh, actually, since we're calling, now we're doing some redundant work that I should actually take out before going to bed, because Struct Polymorph now has some stuff that we don't really need. Okay, this is dynamic respecialize. Ugh. Oh, that's the, okay, hold on. Right, okay. First overload is struct call depth. Second overload has the sorted array. Second overload is what respecialize calls. Then this here is one calling the other. Typer, this is us calling the first one. And then this is regular bake. Oh, fiddlesticks. Okay, the problem is, so I kind of want to change the body of this function. But this is too many problems. So I'm going to do the following really ugly thing. We're going to split it. And this path is going to be eliminated eventually. I'm putting a note down to change that. Okay. So we're just gonna do this. And so it's just a separate project then to move the bake over to use the same thing, which shouldn't be that hard because like function bake also works. I don't know. Anyway, so now let's make sure we still compile. And maybe I'll check in. Well, let's do this. So we should be able to get rid of this and actually this. I hate references, but there we go. So this is just sort of like, we're going to keep getting rid of more and more of this code and merging it in with other code, which is part of why I'm not that worried about making this clean right now. But basically, this is stuff that we're now doing in the caller. So doing it here again is redundant and silly. And this might actually break things. So maybe I should have checked in. What do you mean no site? What? Oh. Please don't explode. There's a possibility of it exploding because we're using different arguments now, I guess. We were sorting the arguments and then resorting them and using that other thing. But, I mean, it's amazing. But it's all working. So this can go. This can go. And this function is now looking a little smaller and more spry and tractable, which is great. And then this part, I think tomorrow we're going to merge into the other thing, which is great. Boy, Visual Studio thinks this doesn't exist for some reason, even though it's been there for 10 minutes and I've compiled the thing fine. Mr. Streamer, how can you live without dot calls? Because they allow the IDE to give you all the informations and IntelliSense. And Roslyn. All right. Fine. Polymorph stuff. All right. So one good thing is you definitely won't have to optimize. We're not optimizing right now. We're improving quality. We're actually making it a little bit slower, probably. Maybe not, but we're improving quality. This is not optimization. This is not what optimization looks like. Oh, hey, Casey. Do I think we will be able to compile programs that can run at frame rates in the high 20s? Or we have to use Clojure for that kind of real-time speeds? Okay, so the thing that I've heard is that functional programming allows you to write programs without side effects, right? And that when you do that, you can use a lot of cores on the CPU, right? Because like side effects means that you can't use the cores, all right? This is what the smart programmers say. So when you use Clojure and you don't do side effects, then you'll scale to the new AMD 64 core machine or the 128 or the 2048 that they'll have in like 3 years, right? And all of those cores will be running the garbage collector. And or, well, I mean, they'll all be running the garbage collector with about 3% of their time, and the rest of the time they will be just waiting on main memory to be pulled into the cache. But you will be using all the cores, and it'll be great. So yeah, I mean, I think if we ever in the game industry want to achieve frame rates in the high 20s, we're all going to have to switch to Clojure, right? And then, like, I never remember which studio is Insomniac and which one is Naughty Dog, but just like those guys did, you're also going to have to make all your content creation tools in JavaScript, because JavaScript is also the future. And those won't run as fast because they're not in a functional language. So they'll only run in like frame rates around the 10s and not the high 20s. But, you know, they're content creation tools, so they're not for the end user. They don't have to run as fast. Naughty Dog is the one that only does gamepad movies now. Yeah. Yeah. No, I mean, what part of what I just said about Clojure was incorrect? Like, this is what everybody knows. Everybody on Hacker News knows that Clojure will let you use more cores because of no side effects. Yeah, the human eye can't even see 27 FPS or whatever. That's why movies are at 24, guys. Movies are at 24 because the human eye cannot go into the high 20s. So like just below the mid 20s was the frame rate chosen by Dr. Steven Spielberg, PhD, DDS, because he knows the human eye. I mean, this is just facts, everybody. Like, I don't even know what the point is of disputing these facts. Peter Jackson tried to do 48 FPS, which cannot be done in Clojure. That's why The Hobbit was a flop. Well, it was a flop because, Casey, the human eye can only see 24 FPS. So when you make your film at 48 FPS, the human eye cannot see half your film, and then people aren't going to understand what's even happening. Like half the movie they can't even see. So like there's like entire scenes that were critical to the plot that people just won't. Anyway, I think I am happy with the progress tonight. We could do a little bit. I don't know. Like this is going to leave. This entire overload is going to go away. So I think maybe the first step tomorrow is to get rid of this thing that we just added, because we just increased the line count by copying this function, but it's all going to go away. Let me see, just so I can like sleep on it. So oh, here we straight up have a do polymorph that takes the bakes. Without did these get generated? How bakes. Argument list. Okay, so we like don't. Oh, we do handle struct here. But we don't put this into an ast polymorph. We literally just frickin' do the, okay. So we're gonna wanna structure this to call struct polymorph. This should probably call the second overload of struct polymorph here. Or frickin' something, like we should have an overload for structs that's exactly these parameters, but with a struct instead of a lambda. Oh wait, bake has a progress on it. It's a do prog. Oh. All right. Anyway, we're going to make this code look exactly like this code, and then hopefully that'll allow us to delete this. I don't know. We'll see. All right. Thank you, everybody, for coming by. There's not going to be any rating tonight because I'm just going to bed. You're starting to write an LVM replacement. You're debating between C++ and Rust. Go ahead and send an email to the address, and if it sounds credible that you are going to do actually an LLVM replacement, I could put you on the beta. The problem is just I get beta emails all the time from people who are beta, and they say I'm totally going to do a thing, and they don't seem to me like people who are going to do that thing, right? So the whole point, like right now, we're just adding people who are obviously going to do substantial stuff, because that's what tests the language, right? Like we want people who are going to stress test the language and make sure it's good. And so, often people send me emails and there's like no evidence that they would do that. And so if you do it, if you're a first year undergrad in college who's never done compilers and you're saying you want to do an LLVM replacement too, like, I don't know. Maybe that's like, it's just sometimes there are people in that situation and they say, I'm going to do this thing. And I'm just like, yeah, you haven't done anything yet. And you're saying you're going to like build the Empire State Building. But if you have done things, then let me know. And we could put you on, and as time goes on, we're just going to enlarge the beta. So more and more people will get on. It's just right now, I'm still stretched a little bit thin in terms of responding to bug reports from the beta users that we have. However, hopefully that'll get remedied soon because we're adding people to the compiler team. So that'll be good. All right. Thanks, everybody. See you later.